Okay, now we have looked at a single amount, a single payment, future value, and we've looked at present value using a single payment. We're now going to make this a little bit more complicated. We're going to look at something we refer to as an annuity. Now, an annuity is defined as a series of consecutive payments or receipts of equal amount. Let me draw a timeline. You'll frequently find when you're working problems that involve annuities or time value of money in general that getting a timeline drawn is very helpful. But I'm just going to draw a timeline so that we can picture what an annuity is. In this case, I'm going to create a 4-year annuity, and the annuity amount is $1,000. So we're receiving $1,000 every year for 4 years. Whoops. Now, we're going to use a formula. We're going to use a table, but there's a formula that underlies this table. But I want to make a point of emphasis here. The first payment of $1,000 that we're getting is occurring at time 1, meaning 1 year before the point at which we're starting. So if we're standing at time 0, we're getting our annuity with $1,000 received at time 1. Okay, not at time 0, not at time 2. Now, annuities could start at any time, but in order for the tables to be useful, the data has to be organized in a way so that the first payment comes at time 1. All right, so this is an annuity where the annuity amount A, we'll typically use the term, the value A. A is equal to $1,000. This is a $1,000 annuity. A just stands for the cash flow of $1,000 that's being received every period. Okay, the future value of each payment can be totaled to find the future value of an annuity. So let's assume we're going to receive a cash flow amount, an annuity amount of $1,000, A, every period for 4 periods. At the end of each period, okay, so the first payment comes at time 1 at the end of the first period, for 4 years at an interest rate of 10%. Well, before we look at the table, let's bounce out and do this in Excel. What I've done here is basically created a timeline. All right, this is a timeline on this side. Time 0 is where we begin. All right, we get our first payment of $1,000, this annuity at time 1, the second one at time 2, third one at time 3, fourth one at time 4. So I've really just built a timeline here and attached the cash flows there. It's exactly the same as what I did earlier a moment ago when I built this. I built the timeline along the bottom, the cash flows along the top. It's exactly the same thing as I've done in those first 2 columns, right here and right here. Okay. Now, I've also calculated the present value of, or rather, here's the future value amount from Table 9-1, the future value interest factor, and I've actually just calculated that in this cell. If you look up here at the top, you'll see that there's a calculation that's made, and what I've done is taken the interest rate of 10% right here, so you'll see it up there at the top, taking that interest rate of 10%, so 1.1, raised to the n, and in this case n is, we want to find the value at time 4, that's the future value, so 4 minus whatever period I invested the money at. So this first one was invested at time 1. This first $1,000 is invested at time 1. So we're going to raise this to 4 minus 1, or 3. So we're going to invest this for 3 years. And when we invest for 3 years, we'll have the value after 4 years. So let's just take the $1,000 times this future value interest factor that I've created. $1,000 received 1 year from now is worth $1,331 4 years from now. So this is actually the future value. The annuity. So that's for the value of the first payment in 4 years is going to be that. The value of the second payment in 4 years, well, it hasn't had as long to compound, it hasn't had as long to grow, it's worth less. It's only invested for 2 years. The $1,000 we receive at time 3 is only invested for 1 year. And the $1,000 we receive at time 4 isn't invested at all. Right? It earns no interest. We just get that payment at the end. It's going to be worth exactly the amount of the payment. We add all of these up. There's a little summation. It's going to be worth $4,641. Alternatively, we can apply a future value interest factor of an annuity, and that's this term right there. We just multiply the annuity amount, in this case $1,000, times a value that's taken from a future value interest factor of an annuity table, and in the table we would find the value 4.641. We multiply by 1,000, we get exactly the same answer that I got doing it through brute force in Excel, using Excel to do it. When we do that, we're just using this future value of an annuity table, and this is the future value of a $1 annuity again. We're interested in a $1 annuity, then we're just going to multiply this value by whatever the annuity amount is. So if the annuity amount is $1,000, we'll take this factor for $1, multiply by 1,000, apply it to every one of those $1,000. So in our table, which you'll find in an appendix to the book, in that table we've got 10%, 4 periods. We find the value of 4.641. Now we've seen where that value comes from as well, because I went through the process in Excel and we saw, yep, $1,000 for 4 years at 10% grows to $4,641. This provides us a little picture of what's going on. Our first payment of $1,000 that we see here grows for 3 years. It gets to be a pretty large amount. It's growing for 3 years. We pull that number from table 9.1, and we get exactly the same number that I got in the earlier in the Excel file. Second $1,000 only grows for 2 years. It'll grow to that amount. Third $1,000 grows for 1 year. The fourth $1,000 doesn't grow at all. We just add them all up. That's exactly what I did a moment ago over in this Excel file. We grew each one of these and added them together. That does it for future value of an annuity.